Okay, so let's go ahead and get going. Today, we're going to be working on kind of reviewing 8.4 and finishing up 8.3 a little bit, and then we're going to kind of start in on 9.1. So today you have due MyOpen Math 8.1. Thursday, you have MyOpen Math 8.4 and also Lab 7. You can turn that in late for full credit until Thursday. So hopefully you folks have mostly got that done in, but try to get that done by Thursday if you can. Even if you get it done by next Tuesday, I think that'll be okay. And then next Tuesday, I'd like you to get 8.3 and Lab 8 done. We have some other things coming up due as well. Please note there is no class on Thursday, April 20th. I'll be at a conference, but we're one day ahead of the Monday, Wednesday anyway, so that works out fine. Then we're, that works out nicely. And then I think I'm going to bump the exam 3 back to May 2nd. So I think that should all work out pretty well. Do you folks need me to go over Lab 7 or any of the other stuff?
Did you go over Lab 7?
Yeah.
Yeah.
Sounds good. All right, so I'll go over kind of all of that. So first of all, there's a couple assignments coming up. There is also the famous mathematician extra credit. I've made that due today, so you could turn it in up till next week still. I didn't really promote that before the spring break, so I should have. My intention was for you to do it over spring break, but I forgot to mention that. So that's just picking a mathematician. There's a bunch of different options of where to find them, or you can pick someone else, some other way of finding them. But try to recognize that famous mathematician. Mathematicians come in all varieties of shapes and sizes. Not just your standard. Einstein or whatever. Okay, but then you do need to claim them using the class choice. So you click on this here, and you'll see some people have already picked theirs, so you cannot pick ones that other people have already picked. You pick a different one, and then just post down below with like their photo, their name, date of birth, date of death, if applicable, a brief biography about them, their mathematical accomplishments, and why you chose them. Great. So just it shouldn't take you more than an hour, less than an hour to do that. And then we have the project. So project part 7 is confidence intervals. So again, remember you have 2 questions you chose. Everyone chose their 2 questions from, we did that survey of 20 questions, and you picked 1 qualitative and 1 quantitative, right? And you wrote them down on here and chose them. So you're going to take your qualitative question, and you're going to create a confidence interval for it, and you're going to take your quantitative and do the same. So qualitative, which one is qualitative? What's a qualitative variable?
Majors? Or
Was that?
how many? What's your major?
Yeah, like what your major is. Yeah, it's qualitative. It has an L in it for label, and so it's categories like what's your major or what's your favorite color, that sort of thing. The thing about it is to make it into a confidence interval, we need to make it binomial. So you'd pick like a liberal arts major or not a liberal arts major or something like that. You'd kind of pick a major or an area, right? It can be a specific major or it can be a group. Do it however you want, and have it be that group or that area or not. Right? If you have birth months, you might want to pick a group of them, like spring months or summer months or winter months, or not. You need to make it into a yes/no thing. The other one is your quantitative data. So again, quantitative has an N in it, numerical. Right? So that would be like your people's age or their height or the speed they drive on the highway, that number. You're going to need to find the mean and standard deviation of those. So it's just like you did for the count A and count in Google Sheets or Excel. You're going to do equals, because all formulas start with equals. That's how it knows it's a formula. And for the mean, we call it the average. So average, and then parentheses, and you can just left click drag the group you want, or you can do it however you did the count A. You can type them in, you know, like B2 colon B, you know, 120 or whatever it is. And you do the same thing with standard deviation, STDEV. So you need to find your mean and standard deviation of your numerical data. And then we're going to take a look at, you're going to answer the questions for me of, or just let me ask you now, so for a qualitative data, like what's your major, is that going to be a T distribution or a Z distribution?
T.
Talk to your neighbors about it. So qualitative, okay, so let me ask you this one. First, is qualitative, is that going to be a proportion or a mean? So let's do that step. What is your major? Can you find the mean of that? No? It's going to be, you know, whatever it is, a liberal arts major or a non-liberal arts major, right? So that's going to be what? Mean or proportion? Proportion. Is that on board? So proportion, is that going to be a Z or a T distribution? Z. Easy peasy. Remember, easy peasy, proportion, Z distribution. And then for our confidence interval for the quantitative question, like how much money did you spend on textbooks this semester? Is that a proportion or a mean? A mean. So is that going to be a Z or a T?
T. T.
T. Remember mean looking Mr. T, mean Mr. T, means are going to use the T distribution. Okay, so just make sure that people are clear on that part. And then here are the actual confidence interval itself. So you're going to do one of these for your qualitative, and you're going to do it again, a separate sheet for your quantitative. So to start your sheet off, you're going to talk about the kind of the intro to it. So for example, for the qualitative, you might say, in a survey of 67 students. They're not necessarily LPC students because we didn't all get LPC students, but in a survey of, you know, 59 students or whatever the number of people you have, found that, you know, 11 of them have a major of STEM, have a STEM major, whatever you pick, nursing major. Construct a 95% confidence interval for the proportion of students who are nursing majors, or whatever it was that you picked. For a mean, you'd say something like in a survey of 97 students, it was found that the mean cost of textbooks they spent, you know, the mean amount of money spent on textbooks this semester was blah, 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 with a standard deviation of blah, blah, blah. Construct a 95% confidence interval for the mean number of money spent on textbooks. Good? So just cater it to whatever your question is. And then you're going to do the following 5 steps for each one. You're going to do one for your qualitative, and you're going to do 5 steps for your quantitative. The first one is see if it meets the requirements. For a proportion, sample is a simple random sample. Yours is not, by the way. Right? We did a convenient sample. We all picked 4 people who knew conveniently, got their information in, pulled it in. That is not a simple random sample. Everybody on board? So you'd say, well, it did not meet number 1 because it was not a simple random sample. But it, you know, maybe it met number 2, and maybe it met number 3, right? That sort of thing. Regardless of whether it met them or didn't meet them, still do the whole confidence interval because I want to make sure that you know how to do the confidence interval. So the rest of the steps are identifying all the values you need, like your point estimate. For a mean, that would be, best point estimate for a mean. Okay, so you're getting close. It's X bar. For mean, it would be X bar. Sample mean. And you'd also find S. Or if it's a proportion, then your best point estimate would be P hat. And then also tell me what your confidence level is, what your critical value is, that sort of thing, just so I know you know how to look those up. And then you're going to find your margin of error, and then find your confidence interval, your lower and upper limits. If you're going to use the calculator and the calculator function, then you do 3 and 4 in reverse. So either way, it's fine, as long as you do those two steps in one order or the other order. So if you did it using a calculator, then you'd say, oh, I'm going to use 1 prop z interval, and what you put in the interval. Just show your work no matter what you did, and then find your margin of error. So your margin of error, you do probably your p hat minus your lower limit, or however you're going to find that. And then step 5, you're going to type a summary. You can either look at your online textbook and tells you where to find it and what it starts with, or you can look at our 7.1 PowerPoint slide, slide 20, or the Warwick PDF. It kind of tells you what to look at. Or you can use the following phrase if you want to write it down. The following phrase would be, we are 95% confident that the true, and then insert mean or proportion, depending upon what's a mean or proportion, of blank, of majors, people who have a STEM major, or people who have of the amount of people studying textbooks, or whatever your variable is between blank and blank. But it should be true, the true mean or the true proportion. That's the key part. We are 95% confident that the true mean or the true proportion, obviously depends upon what's the mean or proportion, of whatever your variable is between blank and blank. Good? Okay. And then you'll upload that. Ideally it's a PDF, but it could be a Word file. You can type it into your Excel file, that's fine, and send me a link to that. You can do a JPEG, whatever works. So either give me a link to it if it's a online doc, or upload it. Either way. And then, and you upload it here under the assignments. Right. So here is the you're submitting a file upload for that. The other one is your Lab 8, which I think I have not set open yet, but I will open that one up. And that is doing a hypothesis test. That one's going to be super, super, super simple because it is only for your numerical one. So depends upon what your numerical question is. You do not really have a choice. You have 3 choices for your claim. So does anybody remember what their numerical one was?
How many hours of sleep you get at night?
Great. How many hours did you sleep at night? So here, you find how many hours of sleep at night do you get at night. You have 3 choices. Greater than 7, less than 7, or equal to 7. You can pick one of those as your claim. So then, does everyone see how this works? So you go to your question, and then you have a choice of equal to some number, less than some number, or greater than some number. And you need to choose one that you think is correct. And then you write your claim. Those who know LPC community college students, sleep less than 7 hours a night, or more than 7 hours a night, or sleep 7 hours a night. You pick one of those. So that would be your claim. And then, does everyone follow that? Does everyone understand what you're saying? I'm feeding you your claim. You need to pick one of those options. And then, you do not need to worry about finding your average and standard deviation because you already found them on your project part 7. Just use those same ones. And they have to be accurate, right? We're all using the same data, so I can go through and check and make sure you've done the correct mean and standard deviation. And then, conduct your hypothesis test using alpha equals 0.05, showing all 5 steps written out nicely, and use your TI calculator. Good? And then you just upload a picture of that, or you can type it out and upload that file, whichever one you want. Okay. Good, good. So that is due next Tuesday, but again, you can turn it in up to a week late. So no worries there. All right, now, what happens if you haven't done an assignment? Still do them. I'm being pretty flexible on getting in your labs. If you're more than a week late, I'll take off some points, but not all points. For open math homework, use your late passes. And again, you can't use late passes after the exam's over. So chapter 6 and before, you can't access those anymore. But chapter 7, 8, 9, you can totally access those up until exam 3. So make sure you get those done. And then, yeah, and do your Excel labs as well. All right, critical values. We're going to kind of skip that part. That's not going to be as important for us in the future. So I want to talk about the test statistic and the p-value. How do you find them? For a mean, stat test, t-test. And you're going to put in your mu naught, your x bar, your s, your n, and your whatever your h1 is. Let's get a reader for this one. Connor, go ahead and read.
P-value is the probability of getting a test statistic at least that extreme. The null hypothesis is rejected if the p-value is smaller than alpha. In other words, if the probability of getting a sample is
Like yours.
I'm not.
But again, quick caution, don't confuse p-value with proportion. Especially because your calculator, if you look at it, it calls your p-value just p. Right? It calls your p-naught p-naught, calls your p-hat p-hat, but then it calls your p-value plain old regular p, which gets a little bit confusing. So make sure that you keep kind of recognize that, write it down as p-value right away, and keep that kind of straight with everything else. Because there's a lot of p's floating around there. Good. Right, and just as to emphasize, you reject the null hypothesis if your p-value is alpha or less. What's our general guideline for unusual? 0.05 or less, or we've now made it extended to alpha or less. So if it's alpha or less, it's unusual. You get something unusual, you reject the null hypothesis. Why is that? Let me check my recording real quick. Okay, we're good. Why is that? The null hypothesis says I am right here, right? And if I get a result anywhere in here, then that's reasonable. Maybe my mean or my proportion really is here because I'm never going to be exactly right in that spot. But if I get something way out here, something unusual, then I'm going to say, hold up, my mean or my proportion is not there. It should be something closer in this direction. So I'm going to reject the null hypothesis. So that's why if we get something out here, we get something unusual, in other words, something with a probability of alpha or less, then we're going to say that our mean or our proportion is not there. Because I shouldn't be getting something so unlikely. My mean must be over here, something, in this range over here. And again, this is our fail to reject region. This is our rejection region. You can kind of think of it as like guilty, right? Something going to trial. We assume H naught is true, the same as we presume someone is innocent. They're assumed to be innocent. H naught is assumed to be true. And then you either have enough evidence to prove them guilty, to prove it, to reject it, or you do not have enough evidence to reject it. So you never prove H naught true. Same as you never prove someone is innocent. You either prove that they are guilty or you fail to prove them guilty. Does that make sense for folks? You convict them or you fail to convict them. You reject the H naught or you fail to reject H naught. You never accept H naught and you never support H naught. You either reject it or you fail to reject it. Is everybody on board with that part? That's going to come up in your homework. So make sure that you're clear on those pieces. You never accept H naught. You never support it. You either reject it or fail to reject it. I'm just going to stop the recording here for a quick second. Good. And then kind of what we're focusing on, there are two types of tests. The first test is when you compare the test statistic to the critical value. That's the traditional test. We're not going to really focus on that anymore. We're focusing on this part here, the p-value test, because that's what everybody does nowadays. So if you do any of the ologies, psychology, sociology, biology, they all use the p-value test. So we're going to be skipping to that. Just as a quick reference, this is the traditional test when you compare critical values to your test statistic. And if you do this one, I'm not going to mark you down, but we're going to focus on this one. It's a lot quicker, it's a lot easier, and like I said, it's what most people use nowadays. So this is what you should be doing on your quizzes. And also, this is the one, if you look at your handout, the second handout I gave you back there, that takes you step by step through all 5 steps. So that was kind of what you can rely on. You cannot use that on the exam, but you can use that to make your notes if you want to. So state your hypotheses, identify the claim. Step 2, write down alpha. Use your calculator functions, t-test or 1-prop z-test, to find your p-value and your test statistic, which will be your z-score or your t-score. And then compare your p-value to alpha. Decide if you're going to reject the null hypothesis or not. So step 4 is all about H0, either you reject it or you fail to reject it. And then step 5 is all about your claim. So what does that mean about your claim? Okay, so do you folks need just another minute or 2 to finish up quiz problem number 1? Let's take a look at some pieces first. So I do want to point out some things. So first of all, your claim is going to be, it's either going to use the word claim itself, or it might use words like, it may use words like, obviously claim, or conclude, claim, test, or it might have a question. So if you find a question mark, like this guy right here, evidence, it's another thing, evidence. Those are all things, reject, claim, those are all things that lead you to your claim. So here, what's my claim? Claim is, this one actually gave it to you straight up, so that's kind of easier. That the IQ scores have a mean less than 124. So that should be a fairly clear claim. Is this a proportion or is this a mean? How do you know it's a mean? Has a mean, yeah, it says mean right there. So my mean is less than 124. Then I highly recommend this. Find the sample or the survey or the selected and circle that section. Does that sort of make sense? So here, a sample of 19 professors. I'm going to circle everything that whole sentence has a mean of blah, 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 standard deviation of blah, blah, blah. That is where I get my N, my X bar, and my S. My mu naught is always in the claim. Let me repeat that. Your mu naught is always what's in the claim. Always. Okay, so that should help you with the pieces to kind of finish this up if you haven't finished up this one. All right, so let's take a look. So here, my claim is mu is less than 124. So step 1, H naught would be, H naught is always, 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 try it again, H naught is always, always, always equal. So that's going to be that mu is equal to 124. Remember, the number always stays the same. Whatever your number is in your claim, that stays throughout all of your step 1. It only changes is the sign, the greater than, less than, equal to part. Since that is not my claim is less than, then H1 has to become my claim. mu is less than 124. So that's my claim. Am I going to use the word reject or support here? So if my claim is less than, my claim is H1, here's H naught. What is rejecting H1? So what does rejecting H naught do for my claim? Does it reject it or support it?
Support.
Supports it. Does that make sense to you folks? So here's H naught and H1. Rejecting H naught supports my claim. So I'm going to use the word support here, because my claim is H1. Whenever my claim is H1, I use the word support, because that's what rejecting H naught does for me, does for my claim. Step 2 is, what is step 2? Step 2 is alpha. What's my alpha?
101.
0.01. Good. Step 3, what kind of test am I going to do?
T-test?
Yep, it's a mean, so I'm going to do t-test. So I need to find my mu naught, I need to find my x bar, I need to find my s, my n, and then whatever my h1 claim is. I need to put those all in here. So what's my mu naught? 124. Aha, I should find my other stuff. So my other stuff I can find over here. My n sample of 19, that's my n, has a mean of 120, that's my x bar, and a standard deviation of 6, that's my s. So all those pieces, n, x bar, and s, comes from a sample of, or this many were selected or surveyed, right? Any of those pieces. So my x bar is 120, s is 6, n is 19, and then my h1. What's my h1 claim?
Less than.
Less than. All right, great. So next, we're going to pop over there. And we're going to do stat, test, t-test of 124, x is 120, s is 6, oops, s is 6, n is 19, and my claim was
The middle one, I believe.
the next one. Calculate, and you end up with a t-value of negative 2.91 or 906, either one's fine, and a p-value of 0.00471. So that's what I get there.
Okay.
So then step 4, what's step 4?
Compare.
Yep, compare my p-value
To alpha.
to alpha. My p-value, I'm going to have 5 decimals there, so my alpha, I'm going to give it 5 decimal places also, so I'm just going to add zeros to the end of it. So clearly 1,000 is bigger than 471, so my p-value is less than alpha. I'm going to reject h naught or fail to reject h naught.
Reject.
Yep, remember, if we're alpha or less, we're unusual. Anytime we get something unusual, we reject the null hypothesis. So it means it's probably not true. So then that means in step 5, blank evidence to blank claim that, what's my claim, less that stat professor's IQ at mean is less than 124. All right, so we got to fill those blanks. Where do we fill them in from? This part here, oops, wrong color. This part here comes from step 4. If I reject h naught, do I have enough evidence?
Yes.
Yes. So that's enough. If I did not reject h naught, there's a not here, then there'd be a not here. I'd have not enough evidence. But since I do reject h naught, I do have enough evidence. Everybody good? Those match up always. The next part, this part comes from step 1.
Support.
What's my claim? My claim is h1, so I'm going to use the word support here always. Whenever h1 is my claim, I use the word support. Whenever h naught is my claim, I'm going to use the word reject. Why? Because I got something really unusual. H naught says that my mean should be 124. I got 120. That is really unusual if my mean is really 124. So that means my mean is probably not 124. So here we have really good evidence that my claim is not 124. It's smaller than 124. So that should support my claim and say, yeah, you're right, it is less than 124. So that absolutely supports my claim. So that's what we're going to use. We're going to support the claim. We're not going to reject the claim because the claim is true. It is less than. So we're going to grab the word support from here, and that's what goes down there. So there is enough evidence to support the claim that staff professor IQs are on average less than 124. Good. Now you folks have got quiz number 2 to do. And again, you're going to find the word claim, and you know, if it doesn't have the claim, then you go with, you know, when you find the words, you find other words, concluded or other things. They'll be a little bit harder sometimes. And then you're going to find the random selected, and that's where you're going to find your. That's where you're going to find your sample part. So I'll give you folks a couple more minutes to finish that if you haven't finished that up.